There's been a number of challenges when it comes to doing API scripting, all those different scripts that we run in Jamf policies where we need to be able to interact with the API. There's always been a certain number of challenges, but now as there are different changes within Jamf, changes within the Mac OS, there are new challenges we're needing to get used to. And I want to talk about the different options that are there, as well as kind of a very different approach that I've been taking. So let's talk about what the basic scenario looks like. And it's a lot of what Chris mentioned. Let's say I've got a policy script, and as part of my onboarding workflow, I want to rename the computer. So much of what I normally put into a rename computer script is already accessible to the computer itself. If I want to get the username, great. I can get that a bunch of different ways, including but not limited to the Jamf default parameters itself. If I want to determine, as I've had clients, is this a laptop or a desktop? Meaning, is it staying put or is it going home? Well, fine. I can just simply look at the model name from System Profiler and see if it has the word book in it. If so, it's a laptop. If not, it's a desktop. I remember freaking out when they announced the studio and thinking I was going to have to rewrite some of my scripts. Luckily, again, still just the word book instantly means it's a laptop. Everything else is a desktop. But for some of the things that we end up dealing with our clients, what if we need to be able to get at information that's in Jamf, but not necessarily on the computer? The most likely example that we keep running into is the asset tag. And by the way, this is just one example of needing to be able to interact with the API within the context of a Jamf policy script. So for the example, if a customer wanted us to be able to name the computer, in this case, D1234, the desktop 1234 for the asset tag, and then the user's name. Okay, great. In this particular scenario, the biggest challenge that we already know, and some of them Chris already covered, kind of like when you go to a movie and you see the movie trailer and it already tells you a lot of the story. Chris covered a good chunk of this for me, but for the moment that script runs, that script exists on the computer in a place that if somebody has admin rights and they know what they're doing, they can actually just copy that script, and then they can see everything your script is doing, including those calls to the API. Now, if I was crazy enough to have included, like in some of my very early days of API scripting, if I included a username and password, for -u username -p password, or even did the username : password scenario, or even if I get to using the basic authentication system of doing the base64 encoded version of user : password, all those things we learn in the 200 and 300 classes. In all of those cases, that information not only might exist within the script, but even if I'm clever enough to put it into the policy parameters and then pass that into my script, anybody who's watching the process table, who's watching activity monitor, who's watching within the terminal, when that script runs, you see each and every single one of those parameters, and I can capture that. And it just, not to belabor the point, it becomes an arms race. You're always trying to, there are different ways around it from the base64 encoding, and also using Jamf has a library for encrypted strings. That's difficult to maintain over the long haul, in my opinion. Plus, you've given three pieces: the salt, the key, and the encrypted string. You're still passing all three pieces of information one way or another. The encrypted strings wasn't meant to keep the end user from being able to get at the information. It was meant that if you had somebody in IT that you didn't want to give the keys to the kingdom, you can encrypt it, and therefore they can have the policy stuff, but they might be able to make the policy and deploy the script, but they may not have access to scripts. It was the idea of being able to separate that information out. But we're still dealing with the exact same scenario. It has been a problem with information security forever. You can't pass secure data and the key to unlocking that secure data in the same channel, in the same communications system. And that's what we're doing. So On top of that, though, we have some additional challenges coming up. A couple months ago, I presented on some changes that were coming in with the API. Now, when you do right now, as things stand at this moment, if I'm using the classic API, which most of the endpoints I access in my Jamf scripts all use the classic API. I just simply pass in that username and password or the base64 encoded string, and I get the information. As of whatever version it was, Jamf has enabled the ability to do token-based authentication. So now I go to the Jamf Pro API and I request a token, but I still have to, for that particular interaction, pass in my username and password. It hasn't fixed it, but I get back this token. And then for the next 15 minutes, I have a valid token that I can make call after call after call with only passing in that token, and it's ephemeral and will go away. Well, but I still had to give out my username and password to do that. So the same challenges we already had of how do I pass around that secure information still apply. But also on top of that, we're now starting with authentication, we're starting to deal with the Jamf Pro API, the newer API, which everything is done returned in JSON. With the classic API, we could request either XML or JSON data. And for those of us who have been doing this for a long time, and especially if you take one of the 400 classes, they show us the tools like XML lint and XPath to be able to, that are already bundled with the Mac OS. And I want to emphasize that this is a command line tool that is bundled with the Mac OS. This is not built into the shell. Anything I'm doing within the shell, I'm still calling out to external tools to manipulate this data. And now all of a sudden we're putting the emphasis on JSON, which is a good thing. JSON is a really good format for this. The problem is, as you'll see in a second, I don't really have the same levels of tools that I did. Another changing landscape thing that hasn't, I would be interested to hear, and I know I've got a couple of things in chat I need to reply to in a little bit. But I'd be interested to know if when it was changed from the default shell of Bash to Z shell, did anybody have any of their scripts break? I was thinking about it earlier this week. I had exactly one, because the way, something about the way one of the test functions, the built-in functions for the shell broke, but that was incredibly minor. But Apple has changed shells once, who knows, actually twice. The default shell has changed in history. Who knows if it would happen again. And then also the other challenges that we're facing are the tools that we use, our shell scripts interact with, have been changing. Most notably, the easiest way to manipulate JSON data is Python. Well, Apple finally got rid of Python 2.7, but they didn't bundle 3, they didn't bundle anything anymore. So what are some possible solutions? How can we deal with not only the security challenges like Chris mentioned, but also this changing landscape? Well, first of all, one tool that we do have already existing in our repertoire is PL-Util, property list utility. Great for manipulating property lists, for being able to change the preferences instead of having to do to the old days of Composer and doing fill user templates to push out property lists. PL-Util and defaults read and write can simply change the property lists in place. PL-Util in Monterey has also gained the ability to extract information from JSON-based property lists, which means that while it is not at all designed to do this, PL-Util can be used instead of reading a file. You can take that data you receive from the API, cram it into PL-Util, and extract the one key you need. In this case, what's the token? But if I'm going to be doing elaborate, where I need to pull out lots of information from the new Jamf Pro API, I need a more robust tool than that. Now, the other way that people have found to get at that token, Rich Troughton or sorry, the first one was Richard. Richard Purvis did a blog post about one method that he did was within his shell script. After he got that data back from the API, he then called an Apple script and had Apple script run JavaScript in order to parse the JSON. Even just saying that makes my skin crawl. That is not having one in the recursion that goes on like Inception to tunnel the way down just makes me crazy. Okay, so what are some better approaches? And I emphasize better better is an arguable term here, right? Like I said, PL util was not meant for extracting one piece of JSON from a variable. Having nested things is not ideal. Some better approaches as far as using the right tool for the right job. JQ, JSON query, is a simple little Unix command. And I could deploy this either with Composer, I could deploy it with Brew, I can deploy it a bunch of different ways, running a script to call Brew, whatever I need to put JQ on all of my computers that are going to be running my scripts, like my rename script, in order to be able to interact with the API. Another option, as I've mentioned before, I still think arguably the best tool is using Python, specifically Python 3. And yes, I can grab Python from some source. I can grab it from GitHub and I can deploy it to all of my computers, just like I would with any other package. I can also use built-in tools to command line tools to have it install the Xcode command tool. Bruce, I believe in my previous discussion of this, was able to riddle off quickly the size of just doing the Xline command tools just to be able to parse JSON was still something like 800 meg, I believe. And then the other option is simply through VPP or through the App Store. I can deploy all of Xcode to be able to get at that. Now we're deploying a couple of gigabytes just to parse JSON, just to deploy the results of the Jamf Pro API nicely. So, okay, as Chris mentioned, we've been discussing this for a long time. What's a better approach? And again, the word better is, I think it's Talking Moose, Bill, has the idea of it's not necessarily a best practice, but a better practice. So what's potentially a better practice than this? I want to keep things lightweight. I want to deal with that security concern that Chris mentioned earlier. How can I interact with the API? How can I have every single one of the computers, every one of my Jamf managed computers be able to interact with the API without adding an extra level of complexity to it? So let's think way outside the box, like outside the physical piece of hardware box you're running. We can use a number of different no-code integration systems. Some I'm sure you've heard of, some I hadn't heard of until a few months ago. Ift.com, if this, then that. Zapier, I did a demo using Zapier not that long ago. Make.com, it's called Make now. If you knew it before, you might have known it as Integromat. They just made the final switch over. A couple of others I had originally on this slide deck, Automate.io, but Automate has already been sunset. So I wouldn't recommend a solution to you that only has 6 months left of life on it. And the last one on here, N8N, I have a little note next to that because with all of these, you are the additional potential security concern. And I emphasize potential. It depends on your particular security teams and your own comfort. You're sending data outside your organization to a cloud system to be able to parse information for you. N8N, which I believe is built on Node-RED from the look of things, you can either sign up for their cloud service or for completely free, it's an open source system, you can deploy N8N to have your own automation system inside your network. You can run it on any basic computer. You could put it in a VM. You could run it as others have, and I briefly tinkered with, run it on a Raspberry Pi. So you can just send that data locally and then get the information back. In all these cases, please do keep in mind, even if you were to have that local, you are still then making calls out to the API anyway. So you're still sending information outside your network. But I also want to point out a couple of the big guns, the big names in this world. AWS has its Lambda functions. Google Cloud has all of its different coding. You can use one of these bigger, more well-known, more, I don't want to quite use the word trusted, depending based on the people in the room, but those names that your security teams are going to be more likely to say, okay, if you're going to be sending information outside. Okay, well, what does all this look like? I want to show off kind of what I've been, a very simple example of this. So if I can get this to work. Hopefully, if all goes well, and I need to move all of you because I can't see around myself at this point. There we go. Can I get a thumbs up that you have a window here showing make.com and over here some code?
We'll give you an audible thumbs up.
Audible thumbs up is perfect considering I just minimized all of your windows. Okay, so what I have here, this is make.com. I figured I showed Zapier before. I could show make this time. So I generate a webhook. And they have integrations with a lot of different systems. But I generate a webhook. It gives me the URL. I can then just take that URL and send data to it. From there, I'm using a service called OneSAAS, however you pronounce that, to be able to run my Python code. So here I just simply paste in my code, and you'll notice that when I hover over this, it emphasizes the webhook. It's able to detect the inputs of one function and what the outputs would be to the next one. Trying to read this code in here, I figure is going to be horrible, which is why I have it over here. Now, I know not everyone in the room is fluent in Python, and I know that reading somebody else's code can be joyous and wonderful. So I tried to keep this extremely simple as a very basic example. Bear with me for a second. So here you can see is where I get that information from the other part of my scenario. I'm pulling in the features that I need in order to do API calls, the different packages. And I have specifically write my code so that these are Python built-in libraries, meaning because I don't have control over installing packages on Python libraries onto OneSAS, I have to use what comes in Python. And as I do note in here, and this, if Chris hasn't already disabled me, this will be disabled by the end of this presentation. But if I were wanting to be even a little more secure, I mean, nobody has access to this outside my team, but I could put this into a data store. I could encrypt this and store it within a database. There are a lot of different ways I could pull this information. So the very first thing I'm doing is I'm doing a post to the Jamf Pro API to get my token. And assuming my token is good, then I'm doing another get call to the classic API. Some of you may recognize this, to get by the serial number. So my computer already knows its serial number. It doesn't know its asset tag number, but it knows its serial number. And then it's sending that information into Jamf, and it's getting back the request. And I'm just saying, instead of having that XML path, like you might see if this was a shell script, I'm pulling out computer general asset tag. And then because I'm being a good citizen, I'm breaking down the token, and then I'm returning the result back to, if I just did this as a webhook without the response, all I would get within that call is just it was received or it wasn't received. By doing the webhook response, I can actually send data back of what that asset tag was parsed within my Python. Okay, great, Chad, but what does this have to do with running a Jamf policy script? That's right, I'm going to change my share to just be the code for a second. So here we have a fairly standard Rocketman rename computer script. We're getting our parameter. If somebody didn't, if Jamf for whatever reason didn't pass in $3, we're getting it through one of the many ways of getting the last user. If somebody didn't pass in parameter 4, I'm passing in that exact URL you saw me get from make. If time permitting, I will cover this. But just like what we were talking about earlier, this is my shell script. This is what is running within my onboarding workflow. When the computer gets to the point of renaming its computer, it figures out its model name, excuse me. And if it contains the word book, it's a laptop. If it's not, it's a desktop. I'm then getting the asset tag from Jamf Pro. And this is where, in this case, I'm hard coding this. Normally you would do I'm surprised I don't have it in here, but you do like system profiler. Oh, it's right here. System profiler, get the serial number. And I'm just doing a curl command, but instead of doing a curl command to Jamf Pro, I'm doing a curl command to my make webhook. And I'm just receiving whatever data comes back. And then I'm stitching it together. I'm saying, what's the kind, what's the asset tag, and what's the user? And for today's purposes, since everybody knows how to do a Jamf policy script, I hope you'll forgive me for not taking the time to create a policy to run this and running. I'm just going to run it here within this command. Now, what I'm going to do is put this back over to the right, share both of these screens again. And I can go ahead and run this script just as if a computer was checking with Jamf and being told, hey, I need you to rename yourself. When it gets to the part where it sends off that command, that query to make, the joys of running a live demo of technology.
You're doing great, Chad.
I'm comfortable with how I'm doing. It's the computer I'm worried about. Okay. Why aren't you running? Okay, something didn't happen. I'm going to make one more attempt to run it as is. It's funny, I had a decent error check in here to make sure it received valid data. I didn't check to see if it didn't do anything. Let's do one more quick little check. Let's make sure that this is in fact the address. Okay, should be. All right, well, that was good because it didn't change. So we're going to try running it again. Oh, okay. I just didn't see it run because I was back here. We've got our success. So now just so I can show off. There we go. The webhook triggers, it runs the code. And even in here, then when I need to troubleshoot it, I can verify what information was sent in. I can verify what the input and output of the function was. And I can verify that the information was sent back through the webhook. And so now I get my asset tag, my model, and my username. So the The trick with this is I'm using an external system to do all the work for me, and it covers all of the challenges that I already had. These services already have the tools I need. In this case, I'm running Python. It has everything I need right there. By using an external system, I'm able to not put a username and password on everybody's computer, albeit how briefly. The script, nothing on that computer contains the information about interacting with the API. It's all stored within this service. Whether that's a good thing or a bad thing, where's your biggest threat? An external service or the users you have in your organization? Anyone who's done system security for any length of time knows that your greatest security threats are the people inside your organization, not the ones outside. Doesn't mean you ignore that. And it deals with, so I've got my parsing, I've got my security, and I've got, I was actually about to say out loud, I've got a nice, reliable way of getting that information. Perhaps that was a bit foolish of me. And like I said, this is just one tool. This is just one example. But and in this particular example, I'm only pulling information from Jamf. I'm looking at the time, and I don't know that I want to go into this unless anybody really wants to see it. As you may have seen within my demo, I already had the hooks in there to ask for a key, because as Chris pointed out, all I'm doing right now is getting information. The risk of somebody outside my organization finding out the serial number of one of my computers, finding my webhook URL, sending that query into the URL, and getting back an asset tag and having something they can do with that asset tag is minimal. In this particular example, I would consider this to be a completely harmless, safe experiment. But what if my webhook is having it update information, update extension hook information? For those of you who've used our break glass admin account, we often store we do store the rotating password within an extension attribute. If somebody has the same level of API access, and by the way, the user that I have created for this demo has exactly 4 checkboxes, and I only need 2 of them. I have read for computers and read for extension attributes. Actually, I only need read for computers. I could have simplified that down to 1. This user has read and update for all 4, for both of those. I mean, all 4 checkboxes. So, I mean, I can make this even more secure, but as Chris pointed out, there is, depending on how elaborate I make this, I still need to think about, because I'm sending data and because this is outside of my control, except for N8N running internally, somebody has the information and somebody has the know-how, and they know what my hooks do. Bad things can potentially happen. The demo that I put together for it, no, I'm not. I was going to show it off. The demo I put together just simply adds an extra fork within my Integromat, make workflow that says that if their information, that secret key, was passed in, then go ahead and do the workflow you saw. Otherwise, there's a branch that goes up, and all it does is return back a error 401, not authorized. So now somebody also has to know, in addition to what information and about my webhook, they need to know what key to pass in. And there are different ways we could lock that down.